All right, we're going to get started here. The order on this next one, I'm going to have Jimmy Klick go first, and then Robin, and Jim Wolf. Where's for her?
So I'm a graduate research assistant at Oregon State University, and I've been there for 3.5 years. And I'm here to talk to you about two of my research projects. And if you were at the North Willamette Port Society meeting, I apologize. This is going to be pretty similar. So just bear with me. But first off, I want to talk about some movement studies we did in caneberries and raspberries using protein marking. So my major advisors are Denny Brook and Wei Yang, and my co-authors are Amy Greaves, Danny Dalton, Juan Walton, Jana Lee, and James Hagler in Arizona. So I'm going to skip the basic introduction of SWD. I figure you guys are very familiar with this past already. So we all know that Himalayan blackberry is very prevalent in the Pacific Northwest, and we believe that, and they're in the field margin, and that's where we believe the flies over winter, build in populations, and then move into the crop from there. So understanding this whole process will help us improve in IPM strategies. So our first objective was to determine the movement from field margins into crop, and we chose two different kinds of field margins. Our first treatment was field margins containing Himalayan blackberry in them versus field margins containing non-hosts in them. And our hypothesis is that you're going to have a bigger problem if Himalayan blackberry is in your field margin. Our next objective was to figure out what is the distribution of this fly near those field margins. And there's regular, random, and then there's aggregated distributions. And we believe that they're going to be aggregated near field margins containing Himalayan blackberry. So just talk a bit about the protein marking that we did. You need to have a way to mark flies to study their movement. So I did a preliminary study, treated blackberries with liquid egg white, cow milk, and soy milk. These are inexpensive marking tools that can be incorporated into a regular sprayer. And then, so I sprayed those plants and I exposed flies to those treated leaves over time and exposed them for various amounts of time. And then I did what's called an ELISA assay. It's basically like a pregnancy test. If the sample comes up blue, that means it's positive for the mark. So I found out that the egg protein was the most persistent on SWD and on the foliage. So then we took that knowledge into the field, and this is in a raspberry field, conventionally treated, and I set up 3 plots in the south that have a positive sign in them. That means that Himalayan blackberry is in the field margin. If it's got a negative sign, that means a non-host was in the field margin, and in 2011 that was wheat, and in 2012 that was grass. And then zooming in on one of those plots, this is how I had the traps laid out. There was 2 in the field margin, which is where I sprayed the protein to mark the flies, and then I had them 30 meters into the field. So here's me spraying liquid egg white into the Himalayan blackberry field margin. And you see right here is the beginning of the raspberry field. And the traps were your basic apple cider vinegar traps, slightly modified with clear cups and a sticky card. And the sticky card is to prevent, you don't want the flies to stick on the card and not drown in the solution, which would wash off the protein mark. So on top we have, I'm going to show you results of flies that were caught in plots that had non-hosts in the field margin. And on the bottom, I'll show you results of captures in plots with Himalayan blackberry in the field margin. So you can see over 2 years, we found 28 flies in the non-hosts. And of those, only 5 were marked. So again, the field marking is treated with the protein mark. And then if we compare that to Himalayan blackberries, I caught over 2 years a total of 836 flies, and of those, about 260 were marked. And if we look at the field interior now, that's adjacent to the non-hosts, I caught 240 flies, 35 marked. But if the raspberry field was adjacent to Himalayan blackberry, I caught about 3 times more flies, and 3 times more of those were marked. So quite a drastic difference. There's more flies captured and marked in Himalayan blackberries, field margins, and in the raspberries over 2 years in 2011 and 2012. So Tom talked a little bit about risk in his talk. So this is, raspberries adjacent to the Himalayan blackberries are definitely at higher risk of fly invasion. Just to back this up, we did some spatial statistics. I'm not going to get into it too much, but basically, again, this is my field layout with the positive sign Himalayan blackberry in the field margin, and where the map shows up red, that means that there's a high density of flies in that predicted in that area, and if it's blue, that means that there's a low density. So this backed up our work. So marking showed that the flies do in fact move from Himalayan blackberries into the crop, and the spatial statistics supports this, and so the blackberries are facilitating crop invasion, and so we need to focus our management strategies on the field margins like Tom mentioned earlier. But we also need to look at some other factors such as host diversity. Tom mentioned wild cherries in the field margins, and those ripen a lot sooner than Himalayan blackberries, so they probably play an important role in increasing the numbers. Also, there's the spatial scale. How far away does a favorable field margin have to be to influence, have a role in crop invasion? And then we need to look at different associations of the field margins and the crop in other systems as well. So that was my movement study, and now I'm going to get into my pesticide work. That was, I need to acknowledge again, my co-authors, Wei Yang, Jana Lee, and Denny Brooks. So we're trying to find reduced risk ways of treating for these flies. And so you all are familiar with these application challenges. There's the PHIs, the REI problems. Aerial sprays are expensive and don't have the best coverage. If you do go in and you have mature bushes, you might knock down a lot of fruit. So all this increases your production costs. And then we're spraying broad spectrum insecticides, so you're disrupting the current IPM programs you have established. And then there's also an environmental impact. So there are some other management possibilities. There's biocontrol, sanitation. All of this has been touched on by Tom earlier. My focus was on reduced pesticide applications. And so one of the things you can do is just skip a row. So alternate row sprays. I didn't invent this. This was back in the 80s. They started doing this in orchards, where you just travel down a row, you skip a row, and then after the second spray treats the other side, so that after 2 sprays, you've treated the entire row. So another option is border sprays, and I did this in blueberries, and I thought this was going to be raspberries only, so I don't have this in my talk, but I have some extra slides at the end, so we can get into it in discussion if you're interested in the border sprays and blueberries. But basically, you travel around the edge of the field, and you spray into the crop, and you use a cannon sprayer to do this, and they typically spray 50 to 100 feet of pesticides into the crop. And so we believe that these 2 methods would be possible alternative management strategies because the fly is so mobile. We showed that it came from the field margins, so if you put up a wall of pesticides, such as in border sprays, you prevent those flies from moving into the crop. Likewise, since we showed that they're so mobile, if the flies are in the untreated area and then they move over into the treated area because they're so mobile, we think that this was a viable method of control. So we tested this, and we did this in raspberries, 3 sites, up to almost 300 acres in size for 3 years, and in a couple different varieties, Meeker, Chemainus, and Saanich. And again, you're treating half a row at each alternate row spray. And all these growers managed for leaf rollers pre-harvest. And this was an every row spray. So they basically cleaned up the entire field first. The pesticides they used were also always effective against SWD. But then they had only 1 to 2 additional sprays specifically targeting SWDs, and these were done alternate or every row sprays. So this is just an example of what a typical field site looked like. This was my biggest site. In red is where the grower treated alternate rows, in blue every rows, and then I had in yellow where I trapped for SWD adults and for larvae, and the larvae I just collected 50 fruit around the trap and did a salt extraction like Tom talked about earlier. And I did this twice a week because we are using this, reduced risk method. We wanted to be on top of monitoring, so I went out there twice a week to do this. And then the green dots just show you where we monitored for non-targets because we believe that spraying less conserves some of the good bugs, some of the beneficial organisms. Therefore, we expect to have fewer secondary pest outbreaks. But I only did this pre and post harvest, and I won't be presenting this data because I'm not ready to yet. So this is a typical spray schedule that we saw. They sprayed every 16 days, so that's kind of a big interval. The recommended schedule is 7 to 10 days, but it also took them a long time to spray. So for the biggest field, it could take up to 6 days to spray because you're dealing with people harvesting and then spraying and REIs and PHI. So it took 2 to 6 days, an average 4 days to spray the entire field. And then they sprayed a total, I mentioned this earlier, 2 to 3 times. And the first spray was for pre-harvest. Okay, so just real quick results. So every row sprays consistently had more adults, which I can't really explain. That was surprising. But the larvae, if you look at the larvae, there's 2 outliers there that had more larvae in the alternate row sprays. But when I ran the statistics on both of these, I didn't get any difference. So similar captures in alternate every row sprays. Alternate row sprays did not result in yield loss. What I mean by yield loss is the loads didn't get rejected from the processor. So these alternate row sprays reduce application time, chemical costs, and areas sprayed by 50%. Again, I just said this, you can combine, but what we did here is we combined these reduced risk, these reduced spray strategies with extensive monitoring. So we, like I said, went out twice a week looking for adults and larvae. We're still assessing non-targets, and I'd like to use Ag Profit and Prime programs developed at OSU to assess economic and environmental benefits produced from these sprays. And so I need to acknowledge all these people and cooperating growers, JACTO, for the cannon sprayer, and my funding sources here at Oregon Blueberry Commission, SCI, and Western SARE. Thank you.
Thanks, Jim. Let's hold on until for questions, and you'll have to get all 3 of these folks down. It's going to be pushed for time here. See, those are really big, yeah. One comment is, that's a really big larval count for no economic losses, but that speaks to...
Yeah, that's 2 years.
Yeah,
For
but...
the entire harvest season.
processing raspberries have a whole lot different tolerance than blueberries. Robin, go ahead.
Hi everybody, I'm Robin Rosetta. I work with OSU Extension out of the North Willamette Research and Extension Center. I work with integrated pest management and nursery crops at the center. Some of you might remember me from way back when I worked with small fruit as well. I really appreciate the opportunity today to Tom's invite to talk about our field evaluations of smart spray systems in Oregon nursery production. Move this forward.
You guys hearing back okay?
You can hear me? Okay, great. I call it smart sprayer. We sometimes call these intelligent spray systems. We had KGW out in the field at the nursery this summer, and they called it a robot sprayer, which was a name that got picked up, and that story moved all over the place. But we ought to get the media to help us make some of our grant research. But this is one of the smart sprayers we're working with. This is actually part of a larger specialty crop research initiative project led by Dr. Heping Su out of the the Application Technology Research Unit at USDA ARS in Worcester, Ohio. This is a multi-state, multi-agency project. We have University of Tennessee and Ohio State University, as well as Oregon State University, evaluating these smart sprayers in commercial nurseries. Last season was the first year everybody got the opportunity to do that. There's a fair amount of research in Worcester with the smart sprayers as well. We've been lucky here in Oregon to have the chance to evaluate 2 of the smart sprayers. The first one was at J. Frank Schmidt and Son Nursery up in Boring, Oregon. This is, and Jim can hopefully help me out if there are any questions with this one. This is a modified GK TR4 tracker. We have the, oops, excuse me. Where's that one? Okay. Oh, I see it. Thank you. So this is the smart sprayer technology retrofitted on half of the sprayer, and the other half is the conventional design of the sprayer. It's got a 30-foot boom, as you can see, and there are these drop-down booms here with the nozzle systems. Anybody familiar with the nursery knows that there's a lot of variability in the species in many of our nurseries, the tree canopy size and that sort of thing. And so the basic objective with the smart sprayers is to use technology, the smart sprayer technology, to basically match the sprayer output to the canopy characteristics. In this case, this uses an ultrasonic sensor to assess the presence and the size and volume of the plants as the sprayer moves down the row. This gives you a little bit of a feel for what is happening out there. There are the ultrasonic sensors, and they send information to a microcontroller box. The sensor analyzer there basically sort of speaks to the variable controller, which signals the solenoid valves to vary the volume of the pesticides based on that information. So if you have a very short plant, or in nurseries, you often have the shade tree nursery, you can have a stick there with virtually no leaves in the early season, and by the end of the season you have quite a full canopy. So without that, basically the nozzles sense again the presence there. So if there is nothing above, if it's a shorter plant, the nozzles will turn off. If there's a full plant there, they'll be on and putting the volume out that is needed. One of our goals with this research is not only to look at the sort of normal evaluation of a sprayer, but is to take it out and definitely make sure that we look at the actual control of the pest. And that's my role. I'm not an engineer. by any means. I just paraphrase Oscar Levant. I've got a smattering of ignorance across a wide variety of subjects. But I'm more a biologist, and to assess the pests in the nursery system, that's a little bit my ground that I'm comfortable with. So what we did was look at powdery mildew on Norway maples. That's a very popular plant for folks to grow, and powdery mildew is a key pest, as well as look at aphids on oaks. So we wanted a disease and an insect at least to be able to assess what we're seeing in the field. Powdery mildew, 75 gallons per acre were applied with the conventional side of the sprayer, and on the retrofitted side, we had 30 gallons per acre. On the aphids, there was only one application in that case, but it was 40 gallons per acre on the conventional side versus 20 gallons per acre on the intelligent sprayer side. This gives you an idea of what we were looking at with assessment. We decided to use a visual rating system because it's hard to pull leaves off and there aren't very many in the nursery. Plus we looked at the newly expanded leaves because powdery mildew can stay on a plant for a long time, so we wanted to make sure we were protecting the new material. We sampled weekly, and basically we saw 0 as no sign of powdery mildew on the top and bottom of the top 5 fully expanded leaves. 1 to 25%, this gives you a feel for what that looks like. Again, both top and bottom side of the leaves. 26 to 50% was our rating 2, and 51 to 100% is our rating 3. And believe me, you can see leaves covered with powdery mildew in some sites. In the aphids, we did strict quantitative counts on the bottom and tops of the leaves, again on a weekly manner on the oaks. And first started off with a very common Myzocallis, is the genus of the species of aphid that we see a lot on our oaks. And then we ended up getting another one on while we were going that was interesting, that the common one is on the bottom around the all over the leaf, and this one stayed on the top. So it's kind of nice for a sprayer evaluation that you have a different aphid on the top of the leaf and a different on the bottom. Turned out it didn't make a difference. And basically what we saw, just to summarize, is that we saw no difference in the control of the aphids or the powdery mildew, despite the fact that we had over a 50% reduction in the volume of pesticide applied. The other sprayer that we've had a chance to evaluate here last season and will evaluate again this season, and Hans Nelson Nursery again in Boring, Oregon, is an air assist spray system. This one is a little different, and actually it's a lot different in a variety of ways. But in this case, we use a high-speed scanning laser in the system. As you can see, it looks a bit like a tower configuration. There are these 5-fingered nozzle systems on either side, so there's 40 nozzles on either side of that sprayer. Okay, thanks. So we're a little bit delayed in this project because they had a direct hit in Ohio at the facility, and it destroyed one of the prototypes. But they built 4 new prototypes for us to work with, and we've been assessing them out here, as I mentioned, in Tennessee and Ohio. That has an embedded PC with a touch screen on it in the cab, solid-state wiring. It's built on a Hardy, I believe, is the base. This is the laser here, kind of diminutive, but since it's about 90 feet out, 30 meters on either side, 270-degree radius. And there's a fan up here. I know in California they had problems with dust, so it blows the dust off as it moves down the field. This is what the signal is basically picking up as it goes down the field. Again, that information sent to the microcontrollers, which everything is color-coded to help with identification of problems, that sort of thing, following circuits. And then the multi-channel system, here again, color-coded. Each one of the nozzles is operated independently, which is one of the powerful things about the sprayer. Again, there's a touch screen in here. The grower operator can actually see the nozzle's firing, so you can see what's going on as it goes down. You can also customize quite a bit of the activities going on there. Oops, too quick there, but there's the fan with the air assist out there. Again, that's just moving the leaves a little bit so both sides of the leaves are covered. Standard nozzle systems, everything on this prototype pretty much was kind of off-the-shelf type of stuff, very readily available. As I mentioned, each one of those nozzles is independently operated. And if you, I think you can just touch to trigger the video, hopefully. I want you to be able to see this thing in operation. This is the sprayer as it's going down sort of a modified nursery that they set up in Worcester to show it. As you can see, sometimes there's these gaps and the sprayers are turning off. And they're turning on when they have a target. So they, at 2 miles an hour, they can sense a target that's a 1/4 inch wide. When I went to Ohio, actually, last January to see these, it was in a warehouse because this was Ohio in January, kind of like this year, very cold. And it was in a warehouse, and as it was going down, I passed all the simulated trees. I saw it fire, and I didn't see anything there, and there was a cable hanging from the ceiling, so it really gave me a feel. If we can go to the next slide. Again, oops, there should be a video. I'm not sure. There you go. We can shoot that one too. So this gives you a little bit of a slow-mo of the pulsing system that comes out of the nozzles there. Anyway, yeah, I'm running out of time. Okay. So I wanted you to see that, but just I'll get to some data real quick here, and we're just going to go real quick over this because, again, there's a lot of trials. We can probably move on. Oh, okay. So they've looked at a lot of tree types, a lot of nursery situations. They've been in viticulture and tree fruit situations as well with these things. They've done individual tests on deposition and on leaf coverage back in Ohio. Very uniform and definitely a good coverage, about 40% in many of the trials. Bottom line, again, a lot of individual trials. As we, in early season, we get the most benefit. As we go through the season, the canopy captures more of the spray, but early season, we're seeing quite a reduction in the volume. But I went to, from all the different trials they've done back in Ohio, they've reduced spray loss on the ground by 68 to 93%. They've reduced spray loss beyond tree canopies by 40 to 87%. And they've reduced spray volume by 47 to 73% using the starting volume application of 50 GPA, which many of you know a lot of folks are generally using 100 gallons per acre. So they had already reduced some of the growers down to that for based on tree row volume types of calculations. So it has a great deal of promise. We looked at rust on shade trees. We looked at a little midge called honey locust podgall midge. Some of you who work with blueberry midge, same genus. In this case, it causes pods on the trees. There's Adriana, our summer intern in the nursery system, and Derek Wells assessing in our plots to give you a feel what our plots look like. And just overall summary of results is, for most of our trials, we either saw no difference in control or better control using the smart sprayer. One of the things we did was compare both the smart sprayer to the grower's conventional air blast sprayer, but also in some plots compare the smart sprayer with the lasers turned off and basically a full plume, a constant rate coming out of the nozzles versus with the smart sprayer technology with the sensor active, so that we could kind of show the growers both to compare it to what their existing things that were, but also in some cases without the variables. Oops. And again, what you're seeing here is we saw with the mildew in the Norway compared to a conventional, a 55% reduction in volume. The honey locust with the podgall midge, a 13% reduction in volume. 2-year pear plots, ornamental pear plots, 7.2% reduction, and in 3-year pear plots, almost an 87% reduction. And I should, one caveat here, I was working with a cooperator who's very conscientious. He actually turned off nozzles in his conventional air blast sprayer to make the comparison because he didn't think that he needed all the nozzles to get the coverage he wanted. So we probably would have had larger differences for some folks who aren't, as diligent in turning nozzles on and off on and varying things that much. But as you can see, there's a fair volume reduction using this technology. They built the prototypes for about $21,000. That's just the hardware cost. That's not the salary of anybody to build it. It gives you an idea, a little bit of that it might, what the range might be. Again, our manufacturers in the room might be able to tell you really what's more realistic there. But again, we have another year out in the field, a lot better data at the end of this year. We have Tennessee and Ohio evaluating different pests than what we have, sometimes the same. So the story's still unfolding here, but we just wanted to give you a feel for what this technology might bring for horticultural applications.
Thanks, Rob.
There are 3 handouts that I brought along that have a lot more information for you, so if you check at the back, hopefully you can grab those one more.
And Jim Wolf with GK. No, I'm saying introduction. All right.
Good morning. I'm Jim Wolf. I take care of the whole goods outside sales at GK Machine. I've been there about 13 years. Started in the floor doing the assembly of a lot of the machines. Pretty much know them from the ground up. And we build 2 different machines. I've kind of put some handouts on some of the tables. I have some more on the back. They are over-the-row machines, so caneberries, blueberries, stuff. A lot of the machines are set up for 4 rows, some with air assist, some with just high pressure and volume. And in others, we've had a customer put an electrostatic system on one of our machines. And the electrostatic machine is in the blueberries for the fly, and he has very good performance out of that. The machine has worked well. The on target, which is the electrostatic system, we built a boom for, and then they attached their system to that. And the customer has had very good luck with that. We also build a TH2 with an air assist using spray air nozzles, getting a velocity of anywhere from 70 to 90 miles an hour through the nozzle, and the spray injected basically through the center of the air stream. And the air spray has been very effective also, and we put up a boom, a drop boom down each one of the rows per se, so we could do almost 6 rows worth of caneberries, 4 rows worth of blueberries, and spray each direction, giving the machine, 1 operator covering a lot of acreage in a short period of time. We feel that one of the things a person needs to do on sprayers is to make sure that you have your nozzles checked, your filters checked, making sure that your coverage is correct. Some people, we recommend 1 to 2 years, depending upon how corrosive the spray is, how rough textured the spray is. Changing nozzles. That way you stay on target with the rates that are recommended by your dealers, fieldmen, because it's just one of those things. If you let nozzles go and they don't show where by looking at them, but in the long run you can add chemicals, add extra water, extra fill-ups. It all costs time. Labor is one of the huge savings that any person can have, and with that labor savings, it's just you can travel further, cover more acreage, and get things done sooner. We are right now in the process. We have about 4 of these track machines going through the shop. We are a custom manufacturer of basically spray equipment from field stuff to over-the-road units. We try and be as efficient as we can. Controllers, we put in Raven controllers in our sprayers, which are controlling the spray volumes by speed. So as you increase and decrease speed, the controller will adjust the spray pump because our spray pumps are driven hydraulically. And that way, you don't have to run a certain speed with a certain pressure. It compensates for itself as it goes through the field. That's about it. I mean, we're just a manufacturer, and welcome to answer any questions.
A little bit more than just a manufacturer. One more share up here, and it's three pretty diverse presentations, but kind of all on the same topic in general. And any questions for any three of them? Any one of them?
Electrostatic application, how is it possible to retrofit an existing air blast with an electrostatic to make it function electrostatic?
It's going to be difficult. It can be done, but it's probably going to be costly. The electrostatics are set up in a system themselves. So like on our machine, they put on 3 different booms, which they were using the air electrostatic system while the charging through the electrical. It was all combined into that unit. So I think it will be a little bit difficult to do that, and maybe even a little costly to retrofit another sprayer.
Okay.
Robin, did you see any difference between your machines you looked at? You had 2 different sensing systems, ultrasonic and laser. Was there any appreciable difference in the efficiency and performance of those sensing mechanisms?
Yeah, the question is basically what is the difference between the ultrasonic and the laser sensor. The laser sensor has the advantage over the ultrasonic in that it can actually sense the density of a canopy versus just the sort of the three-dimensional shape. It can actually penetrate. So it can vary that volume in a more sensitive way. It is more sensitive to the targeted sensing as well. Now, as the nature of such things being more sensitive, it costs more. So that laser on that sprayer that you saw is about a $5,000 laser. And the laser technology has changed quite rapidly, is my understanding, and so that's actually coming down quite a bit in price. But they are becoming more accessible because of that. As you can see, it's in the front of the tank there, so one laser in that particular type of field and that sort of thing can assess out quite far. But if you have a wall of plants, I'm not sure, again, you're going to run up, because I know that we've talked about this with some of the caneberries and spotted wing Drosophila applications. You're still going to have some issues penetrating through a really thick wall of canopy with this sprayer. I mean, it is an air assist that can flutter things around, but I have the same issue with some of the conifers, for instance. And over the tree row design does have some benefits in that you can spray both sides of a canopy, and where coverage is a big issue, and that, again, the density of that canopy is an issue. And those sensors are less expensive overall, so a little different that way.
Questions? Rob, it looked like what you had was very commercial, or very close. Retrofitting and using mill machines and not being terribly expensive. Is there, how do you see that being commercialized? Maybe this is for both you and Jim. I mean, some of those technologies look very useful. How do we move from where you guys are with that to something guys can use in the field?
Yeah, obviously, if you have a $5,000 laser sensor, that's right there, moving it past, you know, as you start looking at the cost, it's going to be a little difficult. I know in California, with other smart sprayer technologies, they had a kit program that they work with basically to kind of help match some of the funding of these new sprayers. A lot depends on your chemical budget. And some of the nurseries in Ohio had $1 million chemical budgets, so an investment in this sort of thing obviously makes it would be adopted fairly quickly because they can pay these things off really in a short amount of time.
But customizing them themselves, their
Well,
sprayers or.
And that, that's I think a big issue. When the nursery industry kind of started trying to, actually a lot of horticultural specialty crops started working with more engineers in the last few years. And one of the things that came out of the nursery industry here is that it's not uniform at all, it's very diverse. They wanted more plug and play, more or less. I already have my equipment for my row size or my container nursery or whatever. Can you give me options to put onto my existing, the retrofit question? I think these guys are probably hearing that a fair amount, whether it's realistic or not, but I think that's one way you can get the cost down. Again, one of our nurseries who saw this said, maybe what we can do is get cheaper lasers, more of them, cheaper, so I think it's just getting people thinking about these technologies, and if the interest is there, manufacturers will probably figure out a way to do it cheaper and better down the road.
I disagree with you a little bit because we're in a pretty critical situation with a lot of chemicals going on and being really heavily impacted economically and environmentally. So it's kind of like, how can we fast track this? Not just get people interested, but actually, how can we accelerate their implementation? Maybe that's more of a question for Jim, too. How do you commercialize this thing?
We were out at the trials that we had out there in Gresham, and it's adaptable, and it is over-the-counter parts. Most of it is stuff that we already sell, so it is fairly adaptable to that. The technology of the computer screen, pretty simple. The brain, the box brain itself, I mean, it's just more or less probably some plumbing on most people's part, and adapting that head system with the controller onto the existing system. So yes, it is doable. I think it will be fairly reasonable once we get some of those out in the field or once guys start doing it. But we noticed, the laser was going to be the hugest portion of that cost, and then the time and labor it takes to actually mount it on. But it all is very adaptable.
One thing my grower that I worked with this last year with this new Air says, I didn't believe we'd have that reduction in volume that you were talking about, but I filled that tank and I had to work really hard. I sprayed and I sprayed and I sprayed. He said he had to go really far, a lot over his nursery and try to figure out new places to spray. Because basically that one tank, instead of doing 1 acre, went 3 acres for him. And that's where the big cost savings for him came in. It's like he could start saying, I don't have to refill this tank as often. That labor is huge. So if I'm going 3 times as far in the same tank, not only the direct cost of the chemicals. The other side of this thing too is we had one day a demonstration with the Natural Resource Environmental Regulatory Community as well. And when you start talking about border sprays and that sort of thing, that's their worst nightmare when it comes to water quality, and they are watching the water. I work with the Clackamas Water Basin Technical Advisory Group, and I try to keep track of what's going on. And so big concerns, malathion and cherries in the water is definitely increased with their pesticide stewardship program. So getting some of that non-target application down has additional benefits to growers under pressure. And I've talked that, even with pesticide manufacturers, somebody said that they're going to hate you if they start selling, a lot less. But the other thing is a lot of growers won't use some of our really good IPM chemistries because of the cost per acre. So if you say, I can't afford $66, $70 per acre for that really nice thing that just stops the, sucking muscles of an aphid. But what if that goes 3 acres now, and that 66 is down to $22 an acre? that instead of, you know, organophosphate or a broad spectrum powdery regrowth. You know, so these things come in, depending on the pest. The thing I like about it is, again, you know, many of us work with a lot of different pests and species, and we try to get the sprays down or get a new one, and the sprays start going up again. This, every swath down the row, you're achieving this effect on multiple species of insects, mites, fungicides. We're not looking at the ground for herbicides, but there's technology to do that if somebody wants to do that as well. So it accrues with a lot of your different pests. So you have to kind of look at, you know, I don't know how many fungicides, it was once 11 a year. I don't know if we're still near that, that Diane had talked about, but you know, over time, you start looking at your chemical budget, these might be affordable.
Is there some work that's being done for, like, the project is still ongoing, so is there an enterprise budget coming out or something, numbers coming out? Because, yes, it would drop labor in the sense of not having to fill the tank as many times, but would it increase labor to maintain, say, the laser system or, you know, more of the intricacies of some of the technology?
Yeah, there is an ag economist as one of the principal investigators. There's actually 11 principal investigators on it.
Yeah.
Pretty diverse: horticulturists, pathologists, entomologists, engineers. You know, it's, and yeah, we are literally. You know, I have to make sure I've got all the chemicals, the rates, how much was actually applied here, and they're going to crunch those numbers here and be able to get a better feel for that. The nice thing here too is USDA is the lead. If this was one of the respective universities as the lead, you'd have all that, a little bit more of the patent and licensing issues than USDA is much simpler. I'm sure these guys can speak to that. I think organization to work with that way. So yeah, part of it's going to be economy of scale over time, and yeah, there's always been limits. Smaller growers often can't, but I'm hoping over time this is an adoptable technology.
And a lot of my point of view is, everyone talks about the disruption of our IPM programs. I mean, you can put together what Jimmy's doing with different spray styles and parts of the field with new technologies and what you're targeting, and with the chemistries we've got available, and you've got amazing amounts of area for making them more affordable and less impacting. Right? We've got to start putting together a bunch of these different strategies. Let's
Yeah.
come together.
It's very versatile that these guys again have made it so you can customize. In a nursery system, for instance, you might just do a border application. You don't need to spray the canopy if it's the one going into the trunk. So you can tell that sensor only assess where I have a trunk coming. When we did the demonstration at Blueberry, or close to Blueberry Field Day, we had a demonstration up in North Willamette, and it was actually in the Caneberry varieties, and there was a mist there, so we just had 2 posts and 2 wires. And as this went down there, we could see it spray the post, but the operator in the cab said no, it was spraying just those 2 wires as it went down. But you can, fungicides, you can, or if we start getting blueberry trees, and you're only working on a fungicide, then you can say, I don't need to spray the bottom part, I can just spray the upper canopy. So there's a lot of versatility. Time will tell with this, you know, the technology is getting cheaper and getting better. It's been around for over 30 years. I know the Davis folks were working with it when I was down at Davis, and that was eons ago.
And it's one of my frustrations. You see these great research things going on publicly, but then getting them commercialized is the problem. It's a great idea. Why aren't we in the field? And that's the bottleneck.
They have to be field hardy. That's the one thing I keep getting back from nursery folks. It's going to break out there with just a few uses. These particular prototypes were built by somebody who was raised on a farm and knew what it would take. It's got quick release technology to, you know, again, things like the color coding so you can track things. And then what the manufacturers do on top of it, they have a lot of ground experience, you know, especially locally what you need.
Any last question? Last chance? Let's give them a hand.